and it's based on the Symfony 2 components. And it's really easy to install and get started. The whole goal for Silex, original use case, was how do I map a URL to a controller? It's just the routing layer and a small abstraction so that you have a controller interface. It was created by Fabian Potencier, the founder of the Symfony project, and Sensio Labs, and Igor Wielder. And it's licensed under the very liberal MIT license. And you can find out more at silex.sensiolabs.org. So a little bit about the Silex philosophy. Silex being a micro framework does have some limitations, and these are intentional. Silex will never support some of the following, like a command line tool, or any feature that would require a command line tool. Anything that's not PHP-ish, like annotations. So Symfony 2 uses lots of annotations by default. You'll never see them in Silex. And anything that adds a lot of code to the core, right? The whole goal is to keep Silex extremely small. So why use Silex? A full stack framework really is overkill for a lot of simple tasks. If your entire goal is just to map to provide some basic structure in a PHP project, Silex is likely a good fit. If it's just about mapping a URL to a controller and providing a way to manage services, Silex fits really well for that use case. But at what point do you need to evolve past that? So again, it's really dedicated towards mapping routes to controllers. And Silex is not Symfony 2. It's built on all the Symfony 2 components, but they have two very different philosophies. The goal is to be concise, extensible, and testable. So all the code that I'm going to walk through today is available on GitHub. I've reused this talk from a prior conference. So if you go to github.com/Dustin Whittle, there's Silex Symfony Live 2012. You can clone it and follow along. So it's very easy to install with Composer. How many of you are familiar with Composer already? Hopefully everyone. So if not, Composer makes it easy to manage PHP packages and to install them. So you can simply get started with curl-s gitcomposer.org/installer, and it will install the Composer UI. And once you do that, you simply need to create a Composer JSON file with one package. So here I'm saying I'm creating a new project, Silex Hello World, and it has two dependencies. Dependency on PHP 5.3.3 and above, and Silex 1.0 and above. And that's all you really need. And then the auto load bit, but this is handled by default now. Once you've created a composer.json file with the structure, you can simply run composer.var install, and all the dependencies will be installed for you. So Silex also has its own dependencies, so it'll install a bunch of Symfony 2 components and make those readily available. A simple app structure for Silex applications is very straightforward. It's simply an index.php front-end controller and the Silex dependencies with your Composer JSON file. But what does Hello World look like? So this is obviously the easiest example. You simply include our autoloader. Then you can reference the Silex application. So to create a new Silex application, as simple as app new Silex application. And then to map Hello World and to use request parameters as in your view, you can simply create app. The HTTP method, in this case, it's a GET method, GET HTTP request. And then I want to map /hello/name, where I want to use name later in my controller. So here it's just a closure that accepts name and then returns hello and then whatever name you pass into the request. Pretty straightforward. But a lot of times you need to do a lot more than this. So what happens when you need additional features? So if you go to your browser, it looks pretty straightforward, /hello/Symfony Live, and then hello Symfony Live, hello ski PHP. Feedback? Yeah, but I think I've sorted it out by just holding on to this. Magic. See? The only presentation with magic trick. So, it's very easy to bootstrap with Composer. Not only to install Silex as a dependency, but you can create a project with Composer very easily using a default structure. So Fabian has a Silex skeleton project that you can use. So it's just composer.var, create-project, fabpod, silex-skeleton. So what does an app structure for Silex look like? So one, what are our goals when we have an application? We need a way to manage some configuration. We need multiple environments in a configuration like dev and production. you might want to handle error cases, like what happens if we have an exception, or if I go to a route that's not found, or a 404 page. And then some level of views.
It's no longer coming over.
No.
Can you guys hear him?
It's not. I can hear him from his voice, but it's no longer coming over the speakers.
I think it's a little overkill. Can everyone hear me if I just speak like this?
Yes.
Yeah, we're good?
Yeah.
Okay. So, yes, an app structure for Silex is pretty straightforward. In this case, we want to handle configurations. We want to handle views and layouts. We might want to add a console command in our project. And we want multiple front controllers to handle the different environments, one for production, one for development. So Fibby makes this really easy with the Silex skeleton project. Create dash project, fatpot, Silex skeleton, and you'll get a project with this structure. So basically what this will do for you is give you a couple of different things. So one, if I go to a 404 page, I'll get a page not found and I can customize that for my application. If I throw an exception in production mode, I'll get a pretty error page like internal error, or sorry, oops, something bad happened. But in development mode, I can leverage all the tools that the Symfony community enjoys. So pretty exception messages with call graphs and useful error messages, but only in the dev environment. So it has the concept of environments and it allows you to leverage Twig for views and layouts. But oftentimes you need a lot more features, right? So how do you add features? In Silex, they're called providers and they're really easy to add. A provider exposes functionality to a Silex application. And really all it does is expose a service in Pimple. So Pimple is a dependency injection container that's very lightweight. And that's really the core of Silex, is how do I register services? And I'll get into that in just a second. But just like the Symfony community has a very large collection of bundles, the Silex community has a large collection of providers. So almost all the features that you normally want to add are readily available. So there are some core service providers that essentially provide the integration glue between various Symfony 2 components that provide a lot of standard features that most people end up using. So how do you handle URL generation and routing? Not just mapping the URL to a controller, but how do I do the reverse? How can I say I want to generate a link for this blog with this post ID and use the pretty title? How do I handle session state, forms and validation? Security and translations, internationalization is all can be built in. HTTP caching, the Twig if you want very powerful view layer, Monologue for standard logging, Doctrine for the database abstraction layer, and SwiftMailer for sending email. So adding each service is pretty straightforward. I'm just going to go through a bunch of common examples, but they all follow the same format. I have a Silex provider that I need to register with my application, and then I can use the service that's provided. So here you simply call app register, new Silex provider, URL generation service provider. And now I can start using this later. So here I can say app get slash, and I can more importantly find it and call this slash URL with the get HTTP request with the slash URL, the homepage route. And now I can generate a route to the home page and it knows that that's a slash. And an example of this is when I want to generate a URL, I might have navigation, and now I can start using the service. So I have app get, when I go to slash navigation, I simply want to return a URL with the URL generator component. So the app class is essentially a container, and the URL generator is a service that's provided by this service provider. And now I can simply call app URL generate homepage. So I've exposed a new method here with bind, and now I can leverage the URL generator below. So now I can have basic routing in my application. And I like to keep this fairly casual, so if there's any questions along the way, feel free to just shout out. The same with sessions. Session state's very common. It's very easy to add. Here we're just going to register the session service provider, and now I can call app session set user with some data, and then I can retrieve it later with app session get user. And then I think most projects need some basic view layer. Unless you're building a REST API, you're going to want some sort of powerful view layer. In this case, Twig's a great library for this. So you can register the Twig service provider with a path to your templates. And then you can call the render method just like you would in a Symfony 2 project. So in my controller, simply call app Twig render and then the path to the template with some optional parameters. And then again, using the URL generation service, bind it to a rel called homepage. So there's more complex examples like adding translations to Silex. So this requires more configuration. This gets mundane, and usually this is where I start to decide whether I want a full stack or not. But here I can simply call app register translation service provider, pass in the default locale or locale fallback to English, and then I need to register some translations. So we're going to register a dictionary with 2 messages, hello and goodbye, and English and French. And now when I want to use those, I can simply automatically will sort out the locale from the URL, specify a message to print, and then tokenize a name as a request parameter. And then I can simply call the app translator service and translate a message. Pretty straightforward. If you use any of the Symfony 2 components standalone, it's very similar to rolling this into an application. And then adding forms. So forms are pretty complicated. I don't want to get too much into the specifics of the form components, but at a high level, you simply register, again, app register, it's a container, the service provider, will register the form service, and I want to match any URL, whether it's a GET or a POST, because I want to show the page on a GET and then process the input on a POST. So here's our controller. We accept a request, so we have access to the request data, request parameters, and then I can use a form factory to create a form element itself and then bind and validate. So all we're doing here is using the form factory to create a form builder rather, and we're just adding some fields. So here we have name, email, gender, choice with a list of choices, and then we're going to return a form instance. And in this case, yes, Jeremy.
Hypothetically, if you didn't want your form there, could you make that form like a service and then just refer to it?
Yeah, absolutely. So I've condensed all of these to one file so they fit on slides, but in just a minute I'll elaborate how you can restructure all of this so it's much more reusable. So the goal is that you can put all of this in one index.php file to see from beginning to end what's happening, but then later abstract it out if you need that level of abstraction. So here we're just simply creating some form elements, and then we're having some logic. So if the form is a post, I want to bind the request data to the form. I want to check the validation. If the form is valid, there's no validation errors, I want to do something with the data, like persist it to the database and then redirect. Otherwise, I simply want to create a form view and pass it to the twig layer, to the template. So on a GET request to /contact, it'll simply render this index.twig with the form element from the create view. But if it's a post request, so I show the page on a GET request, I click submit with some form data, it's going to get caught by the request method is now post. I can bind the data, check for its validity, and do something with the data. With all the power that comes with the Symfony 2 form and validation libraries. The validation is a little bit more complex to explain, but hopefully is relatively straightforward. Because I added internationalization early, you'll see that I've registered the translation service provider and the validated service provider. So here what we're really doing is defining constraints for each one of the form fields. So a name needs to have a minimum number of characters, an email address needs to be asserted it's a valid email address, and gender needs to match the choices that I listed earlier. So it's the same form from here. We have a create builder with name, email, gender, and choice. And now we're going to create the form, but we're going to specify constraints this time. So here we're adding the same name, which is going to be a text element with constraints. So it needs to not be blank, and it needs to have a minimum length of 5. Then we're going to add an email that should assert to be a valid email address. And then again, the same gender choice, but now with the constraint of being 1 or 2, 1 for male, 2 for female, or whatever you specify. And then I'm going to get the form, and then the rest of the code looks the same. Except for now I have additional validation. And this is what it looks like in its simplest form, as I in my twig view, in this index.html, index.twig file, I simply have a form action with a reference to the URL, the form widget that I passed the form component to, and then I can click submit. So caching, how many of you use HTTP caching by default? 1? So yeah, it's pretty straightforward. Basically it uses the HTTP caching specification to add the appropriate HTTP caching headers, depending on the content and how long you want it to be valid for. So in this case, we simply want to make this content valid for 5 seconds, and you can simply register the HTTP cache service provider, specify a directory where I can write my cache files to, and now when I return responses, I can add cache control with a shared max age of 5 seconds. And now this response is going to be valid for 5 seconds. The first request is going to generate the HTTP response, cache it to this directory, and then any subsequent requests will check whether this is still valid for 5 seconds, and then if it is, it'll pull from the cache. If not, it'll tell you to regenerate them. So this works best if you have a reverse proxy in front of your application to manage the actual caching. But it seems like it doesn't really apply to everyone here, so we'll skip right past it. And then there's the Doctrine deval. So the Doctrine database abstraction layer is separate from the ORM. It's really just an abstraction around the PDO interface. So here you're simply going to register the Doctrine service provider, which is specifically just the database abstraction layer, and pass in the PDO settings. So here I want to use the PDO SQLite driver, and I want to specify a path to my database. So the current directory /app.db. And now when I run the SQL queries, I can simply run appdb, fetch associative, select star from table. And if you're looking at appdb, it's basically a PDO instance that you can use. So what I like to use microframeworks for are very simple REST APIs. When all I need is to consume some data and persist it, and I don't need translations, I don't need a lot of validation, I really don't need a full stack. I just need something to map URLs and then provide access to the database. And a lot of times it's just a proxy to a web service. But if you wanted to write a REST API to talk to a database, it's really straightforward. So here we have apt-get /to/do/some-id. We want to have a controller that accepts the ID and then run a query. So select star from to-do where ID is the ID that we passed in. Call appdb, fetch associate with the SQL query, and then the ID. If there's no to-do, I can simply call app abort, which will throw an error page saying there's a 404. Otherwise, I simply want to encode via JSON the to-do item and return it to the user. Any questions so far? All right. And again, all of these examples are the same. So if you take a look, we lost audio, I think. All of these examples are really the same. You simply register a service, and now you can use the service below. So Monologue is the same way. You can use Monologue service provider, pass a path to the log file, and then you can use the Monologue service, add Monologue, add debug. And it could be add warning, add error, etc., depending on the severity level. And all of these are, it's just the Monologue class exposed as a service. For slightly more advanced examples, sending email. So here I want to have a contact page where I can accept feedback and then send an email afterwards. We'll take the form from earlier, and now in our controller, we'll simply use the Swift mailer service to create a message and send it via email. So here we're registering the Swift mailer service. We have an app post. If I post the /feedback, I want to take this data, take the message from the request parameter, the message request parameter, and set that to the body of the email, and then call appmailer, send this message, and then return a response. Usually, if you need security, I tend to shy away from microframeworks, because if you need anything more than basic authentication, you probably need a more advanced security layer. So while you can use the full Symfony 2 security stack in Silex, what you'll quickly find out is the configuration becomes daunting, and you probably want something that's much more structured than Silex provides by default. So here we're going to use the security service provider. We're basically going to register a security firewall that says the admin firewall matches anything with that starts with /admin. And I'm going to redirect you to /login, and I'm going to validate /admin/login check. And then there's a lot more that goes into this, but basically I can give a hard-coded list of users, or I can tell you how to look them up from a database or LDAP or web service or whatever makes sense. In this case, they're simply hard-coded. So I'm saying I have an admin user with a role admin and then some additional metadata. And the way it works is once you've authenticated, you can simply call app security and get the token, where the token is the user itself, like the user object. Okay, so let's dive into some more elaborate examples. So what is a full stack framework? A full stack framework provides a default structure. It provides default conventions, and it provides some configuration. When you compare it to something like Symfony 2, Symfony 2 provides several ways to do configuration. XML, XML, YAML, raw PHP, INI. There's a lot of different configuration settings. But more importantly, somebody's decided all of the defaults for you. Somebody's decided here's where controllers go, here's where model classes go. All those design decisions and architecture decisions have been made for you, and they're usually slightly difficult to change. So in Symfony, anything can be customized, but a lot of the times, if you want to make all those design decisions yourself, then you should use something like Silex. If you're working on a very large team and you want there to be one right way, it's good to be able to refer to the docs that say, okay, controllers live here and model classes live here, and here's how views get registered. And it makes it much easier to collaborate as a team. But a lot of times you don't need that, right? A lot of times you want to own all the design decisions, and that's where I think a micro framework is key. So in Symfony 2, you remove features by default. Okay, I turn off internationalization. I want to disable the security layer. I don't want to use Twig. I don't want to use SwiftMailer. In Silex, you add every one of these. So all the slides I went through are the same examples again and again. I simply register a feature. Okay, I want forms and validation. I want HTTP caching. I want a security layer. I have to register each one of those and then give it the default settings and the default conventions. With something like Symfony or Laravel or any one of the big full stack frameworks, Cake, or there's many of them now, you don't get to make those decisions. And oftentimes, it's really hard to undo. So in general, when asked why choose a full stack over a micro framework, I say it's when you want to remove features, you go full stack. And when you want to add features, you go micro. It's pretty straightforward. But a lot of it depends on what features you want there by default. So what happens when you want to scale Silex for larger applications? All the examples I show are of one file. They're really straightforward and simple. You expose new functionality with service providers. So one, I don't want one gigantic file called index.php. I want to move these classes into separate files. I might want to put controllers in one place and move Twig templates to another place. And I might want to add support for additional features, like we've already gone through database and caching. So, like I said, just like the Symfony 2 bundle is very vibrant, so is the Silex community with their providers. So there's already providers for a lot of common services. Like if you want to use a SEDEC for asset caching, minification, and asset optimization, it's very easy to use the SEDEC service provider. If you want to use memcache for caching, it's very easy to plug that in. Or MongoDB, since Jeremy's in the house, it's very easy to use MongoDB's service provider. Same with Redis, Markdown, and pretty much everything you can think of. You don't really have to do much in terms of third-party integration. And most of what these classes, these service providers do, they just tell you how to instantiate a service. So let's walk through a couple projects, and please bear with me with the feedback on the mic while I try to also use a computer at the same time.
I think that's the static service provider.
That is the static service provider. That is correct. Special edition.
From Laravel.
Okay, so we're just going to turn this off for a minute. So I'm just going to open up some example projects that I've built and go through some of the code. So here we have, let's start with the simplest version. The Silex skeleton. So the resolution's a bit bad and the whole white text on a dark background's a no-no, but we're gonna try to make it work. Can everyone see this? Is that working? Kind of? There we go. Okay, So this is the simplest Silex application. I put on a slide earlier, but it's really straightforward. All I want to do is take a request parameter and print hello request parameter. So I simply register the URL slash app. So I create an application, app equals new Silex application, app get slash hello slash sub request parameter. Then I want to take this request parameter, pass it to my controller, and simply print it back out. You'll notice that by default, there are some things like output escapings built in. So I can automatically just call app escape name. So let's take a look. We're going to take this request parameter name. It's required, so it's going to go into this function, which is essentially our controller's closure. And then we're just going to return straight text. So this is going to get returned as an HTTP response. So hello app escape, this name, which comes from the request parameter. Pretty straightforward. Hello world, hello ski PHP. Nothing actually happens until I call app run. That's when they figure out all the routes, they map all the routes, they see what's in the HTTP request data, they map it to a route, gets mapped to a controller, they execute the controller, which returns a view, returns an HTTP response to the end user. Now let's go into some more advanced examples. So, you can call composer create project Silex skeleton, and that will generate this structure. Up on this microphone.
It might be your cell phone?
No, I've tried everything. It's not happening. So, basically what this structure gives you is a couple of things. Silex skeletons from Fabian is just a way to provide multiple environments, integrate with Twig, and give your project some default conventions to use. So we're going to keep everything in raw PHP, nothing in YAML or XML. It's just going to be PHP. So we have a config directory, a source directory, a templates directory, and then a web directory with our two front controllers in it. So what this looks like is we have a prod.php and a dev.php. And all we're doing here is including some basic services and setting up some settings. So here we just want to set app debug to true because this is our dev environment configuration. And we want to add an additional service because I only want to use the logging service when I'm in dev mode, not in production. And then I have my basic app class. So app class is a way of structuring all of your service providers into one place and registering. So we have app equals new application, and then I'm going to register 3 services. So I'm going to register the URL generation service, so I have routing. I'm going to register the validation service, so I can validate form inputs. Request data, and I'm going to use the Twig service provider so I can use the Twig templating layer. So I basically just turned on 3 features for this particular project, and they're abstracted in the app.php file now. And it's simply going to return an app. Now, there's no console command in Silex by default, but there's nothing stopping you from using the Symfony 2 console command and building your own console for your specific project. So you can also do that here. So Symfony 2 provides a console component, and all I'm doing to create my console class is creating a new application with some commands. So I want to be able to run console my-command and do something. In this case, it's just an example. So I'm registering my-command with a definition, and then doing something with the code. And we'll dive into that later. But more importantly, we have our controllers. So there's 2 controllers here. And this is a lot of boilerplate code that you normally wouldn't want to do, but if you're bootstrapping from nothing and you just want to start with a basic structure, this is perfect for the Silex skeleton. So here we're going to include request response, and more importantly, all we're going to do is create a homepage URL, so git / invite it to a homepage, which returns index.html, and then I want to catch any errors, and I want to do something if we're in the dev mode and something if we're in production mode. So earlier we defined app debug as a configuration. And we just want to check if that exists. I want to return an empty response. If not, I want to show a 404.html page or a 500.html page. So what we're looking for here is in the app error class, in the app error method, we're just taking the exception message that was generated. So underneath, the way this works is it's registering a PHP error handler and a PHP exception handler. If an exception, an uncaught exception is thrown, it will use the exception handler and pass the exception to this method, and we can do something nice with it. Like in dev environments, we can simply print out all the details, and in production, we can show a nice page so our users don't freak out. So here we just have app debug, return empty. Otherwise, I want to use the exception status code. In this case, it's 404. If it's a 404, return that page. Otherwise, it's a 500, and return our 500 page. And then we have the templates that are associated with that. So we have a 404 page that says page not found. Straightforward. It extends a basic layout so we can have, so if you're not familiar with Twig, here we have a basic Twig layout. And all we're doing is defining the common elements of our site. So a lot of times you have a global layout that you want to reuse, and for each controller you simply want to inject content into your global layout. So the way that's done in Twig is you define blocks and you simply override your blocks. If you've used Django or a million other templating systems, they're very similar. So the only reason this looks complicated is there's some Google Analytics code, but otherwise we have HTML, head, title, we include a style sheet, include some JavaScript, and then we define a block in the body element. So here we have block content. And now for my index.html page, the home page that we just registered, and this controller class, all we're saying is I want to bind slash to render this index.html page and bind it to the home page route. And then that actual template is pretty straightforward. So I want to extend the layout so I don't have to reproduce all the header and footer everywhere. And I simply want to override the block content with welcome to your new Silex application. Right? It's very straightforward. We just want to replace this content, but have the flexibility of a powerful view system. And then we have our two front controllers. So the front controller is really just to specify which environment I am in, production or development. So usually the way you handle this is with Apache rewrite, Apache mod rewrite, and you send all requests to the front controller, and the front controller interprets the request URL and maps it to an underlying controller. That was a little convoluted. Let's walk through it. So here, all we're going to do is include the autoload. We're going to include our app class, which is really the Silex application. Then we're going to include our specific configuration. Here we just want to include the production configuration, and then include our controllers, and then we can call app run. So now we've moved everything out of a single index.php file, which we had before, and we've added some basic structure. We have a place for our controllers. Now they all live in one file. We have a structure for our views, and we have a templating layer. We have a global layout, and now we have for every controller an individual view, and we have them in different files. And that's what the Silex skeleton project does for you. That's pretty straightforward. Okay. And I'll dive into a more advanced example in just a second, but I wanted to spend a minute on creating your own service provider. So oftentimes you will need to actually register a service because you have to write your own custom business logic. And you might want to integrate with Facebook or Twitter or Google or some third-party service, and they might provide an SDK. So the best example I could find that I think is applicable to a lot of applications is how can I log in with Facebook? Facebook provides an API, an SDK that talks to their API, but how do I register that Facebook class with my Silex application? So we're going to create a Facebook service provider. But you can do this with any third-party library. The only thing a service provider is, it's the integration glue to register the service, the class with the container. So here we're going to take the Facebook SDK and integrate it with a Silex application. So Symfony 2 has a very powerful dependency injection container. Pimple is very lightweight. All it tries to do is show you how to register service providers and be a container itself. So how do I register a service and how do I access a service? So here Facebook requires some API keys. So we're going to specify a Facebook.app_ID and a Facebook secret. And if this were all in a single file and we didn't want to reuse this, we could call app share. App share is how I expose a service. So here I want to register app Facebook is actually this class instantiated. So we're creating a Facebook service, and the way we're doing that is we're using the Pimple service container, which is essentially the app, and we want to share, using the app context, a new instance of this Facebook class. But I only want to register it once, and I want to be able to reuse it everywhere. So here, again, we call app share, which is basically returning an instance of this Facebook class as a service inside of our application. And then the Facebook class requires some attributes like the app ID and the secret. We're going to pull those from our configuration by simply accessing app facebook.appid and app facebook.secret, and we're done. Now, if I wanted to share this, I wanted to publish this on GitHub and make this available as a Facebook service provider, all we have to do is wrap this in a class and show how to register it. So it's the same idea. We're going to create a namespace for our provider, and we're going to use the service provider interface. And all we're going to do is implement the service provider interface and create the Facebook service provider. But the code's almost the exact same. The only thing this requires is the register method that accepts an application. So I want to take the application, call application share, app share, return a new instance of Facebook, and now instead of calling this every time, I can simply register a new Facebook service provider, which will in turn register this as the Facebook class as a service. So now what this looks like is much more straightforward to use. If I want to require all users to log in with Facebook, I can simply register the Facebook service provider, pass in my Facebook app ID and Facebook secret. Whenever I go to the home page, whenever I go to app/get, this is the homepage URL, I want to return an app instance to our controller, so I want to use the app instance in context. I can simply register the app Facebook service and call getUser. Underneath, what getUser is doing is checking whether the Facebook session exists locally. If not, it will return HTTP redirect to Facebook API, ask you to log in, and then send you back to the application, at which point a Facebook session will exist. And then I can return the JSON data for your Facebook user. So if you've ever used the Facebook SDK, it's pretty straightforward. Call app Facebook getUser, and that returns your user profile from the Facebook API. So the way this will work, this is a really simple, this is a complete Silex application that has Facebook authentication. And it's in 15 lines of code. So here, again, we go to the home page, we use the Facebook service that we registered here, which really all it does is provide this service, and we're going to call getUser. GetUser is automatically going to redirect them to Facebook to sign in. We know that if we get past this point, they have a valid user, and we can simply return the JSON response of their user data. Any questions so far? Pretty straightforward. Okay, but what happens when you want everything by default? So there's a great project, all of this code, GitHub's amazing, the open source community is amazing, I've stolen all of this and repurposed it for this presentation. The Silex Kitchen Edition bundles Twitter Bootstrap, HTML5 boilerplate with all the providers enabled and a bunch of examples for how to use each provider. So if you're new to Silex and you really want to understand how to get started with all the different features, I really do recommend this project. It takes the structure of the Silex skeleton app and it provides a bunch of sane defaults. So provides twig, caching, form validation, session security, translation, aesthetic, and doctoring in one application. And you can simply call create-project, clear Silex Skeleton Edition, Silex Kitchen Edition, and you're good to go. And this is what it looks like. So let's actually dive into the code around this, and I'll show you what I'm talking about. Okay, so right away, what you can see is we have support for Flash notifications. It actually looks all right because we're using Twitter Bootstrap with HTML5 boilerplate. It has a security example, so you're not logged in, you can connect. You can see an HTTP caching example here. So this is cached for 10 seconds. If I wait and come back, it'll actually get generated again. We have an example of dealing with forms with all the different elements, styled nice and pretty. and validation underneath. As well as what you can see is it's localized, so you have half English, half French. But
See, the use of file upload resists any styling attempts.
yes, as always. And then you can connect and log in as well. Right, and then you get form validation. And sign in with credentials, and you're good to go. So let's actually look at the code behind this. So just like earlier, please excuse the hiccups. This has not been the smoothest presentation, but the way it's structured is you have Silex Kitchen Edition as a project. We have a resources directory that now we have a bunch of different resources. So we have a place to store our cache. Because we've turned on the Monologue logger, we want a place to put our logs. We're using a SQLite database, so we want to store that somewhere. It has a basic structure. We have a place for all of our assets. We have a place for our translation dictionaries, and then for our views. And then we can dive into the code. So here we have, just like we had in the Silex Skeleton Edition, we have app.php, which does all the boilerplate code to register all the service providers. So if we zoom into this and take a look, we've registered the cache service provider, the validation component, the form component, the URL generation component, the security service provider, a bunch of different services, and all of these are just features that we want to use. The reason I like this project is because it gives you everything, and then you can figure out each service as you need. Obviously, there's a lot of configuration here that you'll need to figure out, and the docs are amazing for this. But most of the services are relatively straightforward, right? Like I went through each simple example earlier, but you want to register a Monologue service, we're simply pointing to the app directory, passing it to a log file. Sorry, we're giving it a name, passing it to a log file, and specifying the default log level. The same with Twig. So in this case, we want to use Twig caching if the option is set in our application, and then we want to look for templates here and the resources used directory. And then we can take a look at our controllers. So our controllers are pretty straightforward. When we're looking at the home page, we see info flash message, success flash message, and basic hello. If we go back, we can see that we have app session, get flashback. We just want to add a warning, add an information message, and add an error message and a success message. And then we want to return the index.html.twig as our view. And then that index.html.twig is right here. So if we go back to our home page again, we can see that the index.html.twig are these pieces below, /hello, and you're not logged in. So the code that powers that is really straightforward. I want to use the layout.html.twig file for our global layout. I want to override the content block and specify hello as an H1. If you're granted the permission role user, it means you're logged in. So I want to show you your username and offer you the option to log out. Otherwise, I want to offer you the link to log in. Straightforward. And then there's a lot more examples, but if we want to go to the doctrine example, if I go to /doctrine, I want to use the Twig service and then just pass a list of posts by calling select star from post and pass it to our view. And the same with the crazy form that we saw. I'm sort of embarrassed to show this code, but this form, quite lengthy, covers every possible element ever known, is actually not that bad. So I just want to add different text elements to our form, a text area, an email, money, numbers, passwords, et cetera, choice options, and really just shows you how to use each piece of the form component, and you can mix and match for the actual application's needs. And then again, we want to handle validation. So here we handle the request, so bind the data to the form, bind the request data to the form. If the form data is valid, do something with the data. In this case, all we're doing is updating the session, saying the form data was valid. Else, there's an error. We simply want to add a global form error. This is a global error. And then update the form saying this form is invalid, and then return the same form. So if we go back and we click submit on our form, it's going to give us the same generic errors. So here's the notification. This is a global error. And then for each one of our form elements, we have the associated validation with it. And so on and so forth. But you should definitely check out the project. It's available on GitHub. It's very easy to get started. I think it's the best way to jump into Silex because it shows you all the providers by default, and it gives you a basic structure to get you bootstrapped on your project. The next one I like is using Silex as a REST API and Backbone and Twig.js as the front end. So this is a very common use case. This is what I think the most common use case is for Silex in my experience, is I want to create a very lightweight REST API, and I want to do all the view handling in HTML and JavaScript. So in this case, we're simply going to combine Silex for the REST API and Backbone and Bootstrap for the front end. And what you get is a to-do list manager. So in my experience, the to-do list is the new hello world, and this is a basic way of showing that. So we have a REST API on the back end running these to-dos, and then we have a pure JavaScript front end that gives us the ability to mark them as completed, add them, and delete them. So I can add a new item, save, and all it's doing really underneath is providing a REST API in Silex. Again, that code is available on GitHub, so you'll hang /Silex-Backbone to-do list if you want to get started. Okay, so when does Silex make sense? For simple applications, I like it the most for RESTful API applications. And Silex really can replace Symfony 2 if you don't need all the additional components that Symfony 2 provides. There's a ton of proven companies using Silex, so obviously Sensio Labs, BBC News mobile client, that's built on Symfony 2, Nomio, KP Labs, White October, Leap, all using Silex underneath. I think I covered this enough already, but when you use a full stack, if you have a large application that requires the structure of Symfony 2, all the default configuration, all the default conventions, if you want all those decisions made for you up front, you should use something like Symfony 2. If you have a large distributed team and you want to point to the source of truth, the Symfony documentation, to say, here's how you set up controllers, here's how you set up forms, here's where views should live, Symfony 2 is really the better choice. If you want to make all those design decisions yourself, Silex is more ideal. In my experience, if you want to use a full ORM, you'll likely want to use Symfony 2. I think this is up for debate, but or if you need a more powerful service container. So Pimple is very lightweight, but it's also very limited in features, so keep that in mind. Pimple is about to get a lot faster. I just found out recently that it's being rewritten in C++ and made available as a PHP extension. C. My apologies. It's being rewritten in C and should be available as a PHP extension soon. So yeah, it's about to get even faster. There's a very active community around Symfony 2 components and Silex specifically. So there's a mailing list, Google Groups, Silex-PHP, Silex-PHP or #Symfony on Freenode, where you can find that guy, and occasionally myself. And then GitHub. If you have issues, the best way to solve those issues is with a pull request. The maintainers of these projects thank you for your hard work. Find out more at silex.sensiolabs.org. And then tons of documentation. So a lot of cookbook common recipes are available. Almost all of these examples come directly from the cookbooks. And then a list of providers, both that are bundled as well as available as third-party services. If you want to contribute, GitHub's the place. If you're not contributing, you should, whether it's to Silex or something else. You can find these slides on SpeakerDeck, speakerdeck.com/Dustin Whittle. Please rate this talk on Joined In, and don't hold the microphone against me. And thank you very much for your time. Let me know if you have any questions. Any questions? All at once? None at all? Enjoy the rest of Ski PHP.